question number 10C, we want to find the equation of the perpendicular bisector of AB, where A and B are the points -4, 8 and 0, -2. So let's go to the new sheet. So we want to find the equation of the perpendicular bisector of AB, where A and B are the points -4, 8 and then 0, -2. Alright, now before we delve into finding the equation of the perpendicular bisector, let's assume that AB is a line segment this. So let's say A is here and then this is B. So a line that is meeting A and B at right angle, it is perpendicular to that. We call it the perpendicular line. And now this line bisects AB, meaning that it puts A and B into half, which is the same as finding the midpoint. Where it is bisecting AB is called the midpoint. Now anytime you want to find equation of a straight line, you need a point on it and then the gradient of it. So in this case, we can use line AB to find the gradient of the bisector, because the bisector is perpendicular to AB, and any point on the bisector is the midpoint of AB. So let's see how we do that. So we can locate the point which is here, the meeting point of the bisector and that of the middle of the AB. So the point will be here, and we need to know the gradient of this line, this particular line here. Then we can find the equation by using y minus y1 equals m into x minus x1. So now how do we find this point? This point is the midpoint. So we have to use the midpoint formula, which is giving us the midpoint is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. It simply means that in a coordinate form, just add the x ordinates and divide it by 2, and then the y ordinate and divide it by 2 to give you what? The midpoint. So let me clean this first. Alright, so the midpoint will now be -4 plus 0 divided by 2, comma +8 plus -2 divided by 2. So when we simplify that, it will be -4 divided by 2, and this will be +6 divided by 2, and that will give us -2, +3. So where it is bisecting AB, that point on the line is -2, 3. So to find the equation of a straight line, you just need a point on the line, and a gradient is one of the ways to solve the equation. So now let's find the gradient of the bisector. We know the point -4, 8 and 0, -2. So we use it to find the gradient. So let me write this point here as -2. We'll use it. So -2 and what? 3. Alright. Okay, so let's find the gradient. Gradient is giving us m equals y2 minus y1 all over x2 minus x1. Okay, so if you use the point AB, our y2 will be -2 minus our y1 will be +8 divided by our x2 is 0 minus our x1, which is -4. So when we simplify this, we have -10 divided by +4, and this gives us -5 over 2. So this is the gradient for the line AB. Okay, the gradient for line AB is -5/2. Now this line AB is perpendicular to the bisector. So if you want to know the gradient of the bisector, it is the negative reciprocal of the gradient of AB. So we say M1 times M2 should give us -1. So if you are looking for the gradient of the second line, which is perpendicular, it becomes -1 over the gradient of the first line. So the gradient of the bisector will now be M2 will be -1 all over the -5/2, and that gives us +2/5. +2/5. So let me clean some of this. So it means the gradient that we have to use to find the equation of the line is what? +2/5. +2/5. So M2 equals +2/5, and then with this point on the line. So the equation is y minus y1. You can use other ones, you will also get the same thing. Y minus y1 equals m into x minus x1. So I'll have y minus y1, which is 3, is equal to +2/5 into x minus x1, which is -2. Is -2. So when you simplify this, the LCM is 5. So we multiply through by 5. We will have 5y minus 15 is equal to 2x, okay, and this is +2 plus 4. 2x plus 4. Now we'll have 5y in the general form. 5y minus 2x minus 19 is equal to 0. Is the equation of the bisector, perpendicular bisector. So you have 5y minus 2x minus 19 equal to 0. So thank you for watching.